Hey everyone, welcome back to the channel. Today, we're solving LeetCode Daily Challenge 3330, titled Find the Original Typed String 1. We'll go through the problem statement, the intuition behind solving it, the actual code, a dry run, and of course, the time and space complexity. So let's dive right in. The problem is simple yet interesting. You're given a string called word, which is Alice's typed output. Now Alice might have long pressed any key, at most once, while typing, causing some characters to appear multiple times. Your job is to return the number of possible original strings that Alice could have meant to type. Let's understand with an example. If word equals ABBCCCC, there are 5 possible original strings. All of these are valid by deleting at most one character in each group of repeated characters. Now, here's the logic. We'll traverse the string from left to right. Every time we find a pair of consecutive characters that are the same, we consider it as a place where a long press might have happened. Since Alice can long press any one key at most once, each such spot gives us one more valid possibility. We'll start with a count of 1, the original type string, and add 1 each time we find a repeated character right next to the previous one. Let's now see the code to solve this problem. We start by initializing a counter variable, count, to 1. Why 1? Because the original string itself is always a valid possibility. Then, we loop through the string starting from index 1. That means we compare each character with the one just before it. Inside the loop, we check if word I is equal to word I minus 1. That means there's a repeated character, so we increase our count by 1. Finally, after the loop ends, we return the count. And that's the full code. It's short, efficient, and runs in linear time, just one pass through the string. Let's dry run this with the input ABBCCCC. We initialize count equals 1. I equals 1, B equals A, no. I equals 2, B equals B, yes. Count equals 2. I equals 3, C equals B, no. I equals 4, C equals C, yes. Count equals 3. I equals 5. C equals C, yes. Count equals 4. I equals 6, C equals C, yes. Count equals 5. So the result is 5, exactly what we expected. Time and space complexity is O of n, because we scan the string once. Space complexity is O1. We use only a single integer variable. That's it. This was a clean and elegant one-pass problem. A good reminder that even simple problems can test how well we read and interpret the statement. If you found this helpful, don't forget to subscribe, and hit that bell icon. Catch you in the next daily LeetCode breakdown.